Okay, this lesson is on related rates. It's without question the hardest thing we've done. Um, and you just have to push through it and try to follow and write down everything you can possibly write down that you know, keeping in mind that derivatives are rates. So anytime you're given a rate, see the word rate here? You're being given a derivative. You also have to know a lot of formulas from geometry. So normally when you see a right triangle, you're going to use Pythagorean theorem. You're going to have to know the area of a square, the area of a rectangle, the volume of a sphere, the volume of a cone, the surface area of a cube, those kinds of things. You're just going to have to memorize them. And as we start to go through them again, they'll start to come back to you a little bit. But let's try this problem right off the bat. Right triangle ABC, point A is moving along. So this point is moving that way at a rate of 1/2 centimeter per second. So we're going to say that dA dt. So now everything in related rates is with respect to time. So A is changing at a rate per second, and it's -1/2 because it's going down centimeters per second. Point B is moving towards point C at a rate of -1/3 centimeters per second because it's going to the left, so it's negative. What's the rate of change in the area? So right when I say we're going to use Pythagorean theorem, we're not. A lot of times you do, but we're talking about the area. If you were going to use Pythagorean theorem, it would say, what is the rate at which A and B are getting closer to each other? Meaning the hypotenuse is getting smaller and smaller and smaller. At what rate? That's when you would use Pythagorean theorem. But this says, what is the rate of change of the area? So we want d area dt. That's what we don't know. At the instant when AC is 15 and BC is 20. Okay, now AC is this distance, and this rate we call dA dt. So I would kind of just like to call this, well, whatever, we'll just keep going. Okay, area of a triangle. Area of a triangle is 1/2 BH. We want to know what is the rate of change of this. So we're going to take the derivative of both sides. D area dt equals constant times BH prime plus HB prime. But what are H and B? Well, AC is clearly the H, and BC is clearly the B, right? Height and base of the triangle. So plugging in all of these things, d area dt. Now normally you're just going to use a letter here, but I didn't want to use A because I already used A up there. So equals 1/2 times. The base, B, is 20 at the instant that we're talking about. The change in height is the change in the A is moving down, so that's the -1/2. Plus, the height at this particular instant is 15, and the change in the base is -1/3. And so the d area dt, the area is changing with respect to time at a rate of, we have to do all this math, -10 minus 5 is -15 times 1/2 is -15 halves, or -7.5 centimeters squared per second, because it's area. So the answer here would be choice D. Okay, now I'm going to hand you out in class these problems, and we're going to do them together. So let's start with number 537. So again, you should already have this. I'm going to walk you through it. So assume all variables are functions of variable t. Now normally we've been deriving with y being a function of x, but now we're saying x is its own function and y is its own function with respect to t. So when you take the derivative of both sides, this is what you know. You know dx dt equals 1. Find dy dt when x is 6. So we're finding a rate of change at a particular moment in time. So the first thing I did was when x is 6, I solved for y, because I want to know what y is at this particular instant. So when x is 6, solving for y yields -1/2 for my y value. So then I take the derivative of this equation. First times derivative of the second plus second times derivative of the first. Now I could have written this as dy dt. I don't know why I did y prime, just because that's what I'm used to doing. And that equals 0, because the derivative of -3 is 0. So now we're going to plug in everything we know. We know at this particular moment in time, x is 6. We're looking for dy dt, so we're leaving that as y prime. Plus, we know that y right now is -1/2, and we know that dx dt is 1, and we know that it equals 0. Solve for y prime, and you get 1/12. That's how you do 537. The next one I'd like to show you is 540. 540 talks about the volume of a cube. So again, you have to know the volume of a cube formula, which is s cubed. It tells you that the volume is decreasing at the rate. As soon as you see the word rate, you're being given a derivative. So you know dv dt is -10 cubic meters per hour. It's negative because it's decreasing. How fast is the total surface area decreasing when the surface area is 54 square meters? Well, you have to know that surface area is 6 times side squared. That's the surface area of a cube. Again, just something you have to know from years past. So we can solve this equation to find out that s is 3. So we're talking about what is the change in surface area at the given instant when the side is 3. Keeping in mind that the side is always changing because the volume is changing. So we want to find ds dt. So we are going to take this formula and take the derivative. Derivative of the left is simply dv dt. Derivative of the right is 3s squared times ds dt. Remember, the side is a function of time. Plug in what you know. You know dv dt is -10. Keep the 3. You know that s at this instant is 3. And you want to solve for ds dt. And that's your answer. Again, I know it's a lot, but the more we do, the better you'll be. I promise. Let's look at 541. The length of a rectangle is decreasing at the rate of 2 centimeters per second. So dl dt is -2. That's the first thing I write down. dl dt is -2. The next thing I know, the width is increasing at 2 centimeters per second. So dw dt is +2 centimeters per second. When L is 12 and W is 5, find the rates of change of the area, the perimeter, and the length of the diagonal. So the first thing we're going to do is the area. So area is length times width. At this particular moment in time, I can find out what the area is. Do I need to though? No, I guess I don't need to. So we're going to take the derivative of both sides. Oh yeah. So dA dt equals L times dW dt plus W times dL dt. It's simply the product rule. Plug in what you know. Well, we don't know what dA dt is. That's what we're looking for. We do know that the length at this instant is 12 and the change in the width is 2. And we know that the width at this instant is 5 and the change in the length is -2. And when you perform this calculation, you see the area is changing at 14 centimeters squared per second. So that's the rate of change for the area. Now we're going to go to the perimeter. 2L plus 2W, so the derivative. dP dt is 2 times the derivative of the length plus 2 times the derivative of the width. Plug in your numbers. 2 times -2 is -4. 2 times +2 is +4. So the perimeter is changing. It's not changing. The perimeter is not changing. And then finally, to do the derivative of the diagonal, we need Pythagorean theorem. So, Pythagorean theorem, as you remember, is this. And we want to know, this one's the diagonal. The hypotenuse is the diagonal. So let's call that D. And let's call this L and call this W. So L squared plus W squared equals D squared. But I want to know the rate of change of the diagonal. So I have to solve this equation for D first. So the square root of L squared plus W squared equals D. Now I can take the derivative of both sides. So dd dt, meaning the rate of change of the diagonal, equals, remember I'm going to write this as L squared plus W squared to the 1/2. So 1/2 L squared plus W squared to the -1/2 times 2L dl dt plus 2w dw dt. It's just like implicit differentiation. Every time you take the derivative of anything, you have to remember it's a function of time, so you must also take the derivative with respect to time. So, what do we know? dd dt equals 1/2 times L squared is, what was L in this problem? 12? I forgot already. 5, what number are we doing? 541, L is 12 and W is 5. L is 12, W is 5. So L squared is 144 plus 25 to the negative 1/2 times 2 times 12 times negative 2 plus 2 times 5 times 2. dd dt. This adds up to 169 to the negative 1/2 means 1 over the square root of 169, which is 1/13th, times 1/2 is 1/26th, times 24 times negative 2 is negative 48 plus 20, negative 28. So times negative 28 equals negative 14/13 centimeters per second, because it's the change in the diagonal. So back to the first question, which ones are, which of these quantities are decreasing and which are increasing? Well, the diagonal is decreasing and the area is increasing and the perimeter is not changing. That was just another example. All right, which one should we do next? I would like to do all of these, but maybe you could do some of them on your own. We could just go over them in class. Let's look at 546. The area of an equilateral triangle. So then you should go, oh shoot, I don't remember. So you might have to derive it, or you might have to just go look it up and memorize it, but you have to be able to find the area of an equilateral triangle. Let me show you how you will find it if you don't remember. Remember, an equilateral triangle is 60, 60, 60. Okay. If we call the side S, then this side right here is S over 2, right? And if this is 60 and this is 30, hopefully you remember your 30, 60, 90 triangles, and you remember that the side opposite the 30 times root 3 gives you the side opposite the 60. So your height is S root 3 over 2. Your base of your whole triangle is S. So if you do 1/2 base times height, you get 1/2 times S root 3 over 2, which gives you S squared root 3 over 4, otherwise known as root 3 over 4 S squared. It's the area of an equilateral triangle. I'm sorry if that confuses you, but you have to be able to do it. You have to know your 30, 60, 90 triangles. So this is the area. So back to number 546. The area of an equilateral triangle is increasing, so dA dt equals 5 square meters per hour. Find the rate at which the height is changing, so dH dt is what we're looking for, when the area is 64 over root 3 meters squared. So we know the area is root 3 over 4 S squared. So dA dt is, I'm going to multiply 2 out here, it'll cancel with the 4, so I get root 3 over 2 S ds dt. That's the derivative of this. The 2 goes in front, gets multiplied by the constant, which gives us root 3 over 2, subtract 1 from the exponent, multiply by the derivative of the side. So what do we know? Well, we know dA dt is 5. We know root 3 over 2. We don't know S, but they tell us that at this particular instant, this is what the area equals. So if we set this equal to root 3 over 4s squared, and we solve for s. Hopefully you recognize, multiply both sides by the reciprocal. Multiply both sides by the reciprocal, so that goes away. S squared. 64 times 4 is something big, all over 3. Oh, what's that, 256? Let's see, 64 times 4, 6, carry the 1, 256, yep. 256 over 3, and I want to take the square root of that, which is gross. Square root of 256 is what? 16 squared? Yep. So this is 16 over root 3. And again, we should rationalize that, but since it's in the middle of this problem, we're just going to leave it like that and see what happens. So the side is 16 over root 3, and we're trying to solve for dh dt. Is that what it's asking for? Hold on. Rate at which the height is changing. Interesting. Well, we're already this far. Let's just see the rate at which the side is changing, and then we can figure it out from there. So when I multiply these two, those cancel out. 16 over 2 is 8. So the side is changing at 5/8 meters per hour. Now, this is the rate at which the side is changing. The question is asking what's the rate at which the height is changing. So let's go back to the area of a triangle. 1/2 base times height. In this case, the base is s, which is this. So I'm going to change the b to an s because the base of the triangle is one of the sides. 1/2 s times h. So let's take the derivative of both sides of this. 1/2 times first times derivative of the second plus second times derivative of the first. Okay, plug in what you know. dA dt is 5. 1/2 times s is 16 over root 3. Remember, that's what we found s to be. dH dt is what we're solving for. Plus h, well, we have to find the h. If the side is 16 over root 3, oh boy, I need a new piece of paper. I hope you're finding this fun, because I am, but you're probably like, oh my god, if it's taking you this long, imagine how long it's going to take me. Bah. Get over it. Okay. Blah, blah, blah. What am I trying to find? Here's where I am right now. 5 equals 1/2 times 16 over root 3 times dH dt plus h times ds dt. So I need to find h. I know the area is 1/2 sh, and I know in this particular problem 64 over root 3 is the area, and that equals 1/2, and I know the side is 16 over root 3, and I need to find the height. So this becomes 8 over root 3 multiplied by the reciprocal, root 3 over 8, and I get h equals 8. There's probably a much easier way to do that, but that's how I'm doing it. So now I'm going to replace this h with 8, and I already know ds dt because it's 5/8. And now I can solve for dH dt. So 5 equals, well, first I'm going to multiply by the reciprocal, get rid of that half. So 10 equals 16 over root 3 dH dt plus 5. Subtract 5 from both sides. Multiply by the reciprocal. And that is centimeters per hour that the rate of the height is changing. Woohoo, that was fun. Let's see, where did I do that one? 546. I must have done it before. 546. Look at, I did all this work. I got all the same answers. I got 5 root 3 over 16. Yay, I got the same answer. Isn't that fun? Oh, it's meters per hour. Okay, so there's 3 or 4 problems to get you started. I'm going to assign you some out of the book. I really hope it kind of makes sense. Basically, you write down the formula, you take the derivative. You have to remember everything is with respect to time. We are going to practice this for at least 2 more classes, so don't stress out too badly. And happy related rates.